Yeah, this is Mr. Eke here. On this video, I want to talk about an alternating current. And remember the previous video which I posted on electromagnetic induction. And according to examination guideline, we expected to know how generator works using the principle of electromagnetic induction. But in order to do that, let's just break it down. If you look at it here, I have a magnetic field which moves from the north to the south. Then I have the rotating coil. You can see the coil moving here. Let me make it stationary for a while so that we get used to the parts first before we start. And you can see I also have the bulb. I have the galvanometer, oscilloscope to show us the graph of alternating current against time. And here comes the magnetic field. Let me show the direction of the current so that you should be able to understand the setup clearly. And if you look at it here, you can see a distinctive features here. The slip rings, this is one of them, this is another one, and you can see the two brushes in contact with the slip rings. So let's allow this AC generator to work so that you'll be able to see exactly how it functions. And permit me to start with the bulb. If you look at it here, you will see that once the coils begin to rotate, we said there will be a magnetic flux. There will be a change in the magnetic flux. And as you can see here, there is a change in magnetic flux here. And that change in magnetic flux is what is going to produce an induced EMF. And the induced EMF is what is going to generate the current. The change in magnetic flux induces electromotive force or the voltage in the coil. And according to Faraday's laws of magnetic induction, a charge in the magnetic field induces an electric current in the coil. Then the induced EMF causes an electric current to flow through that coil. So that is as simple as that. We can also see that the current produced by the generator flow from the coil and is connected to an external circuit. And the external circuit can be used to power various devices. And I want you to pay particular attention to the slip rings, which must use to identify any generators given to us. Here, remember, I've identified it as AC generator because of the slip rings. If it is a DC generator, we expect to see a split ring. So we are going to talk about that in our next video. But basically, let's compare this AC generator to a DC generator. And based on the definitions, AC generator, it will convert mechanical energy, it will convert it into electrical energy, and that electrical energy will be an alternating current. While in the case of DC, it will be a direct current. And you remember that in the AC generator, the electrical current, it reverses direction periodically. That's why it's alternating. The current reverses periodically every half of the cycle. But in the case of a DC generator, the current flow in one direction, unidirectional. The direction of the current does not change. Now, in case of their structure, with regard to their structure, an AC generator has a slip rings. You have a slip rings, while in the case of DC, you have a split rings. And this is very, very important because we can use that structural differences to differentiate them. We can use that structural differences to differentiate them. And most often, it's also worth mentioning here that because DC generator uses